In the following 2 videos, we focus on a functional brain domain that we all can relate to, emotion.
The concept of emotion is used in everyday language for various types of strong expressions, such as passion, sadness, anger, fear, and hatred. But emotions are much more than that. They are part of a wide range of behaviors, such as social interaction, unconscious risk assessments, stress reactions, empathy, the brain's reward system, its fear system, just to name a few examples with obvious relevance to psychiatry.
It is fascinating to realize how the emotional systems can be regarded as just another set of behaviors, like the motor or sensory systems, that have its own biological substrate and its own dedicated brain regions and neural networks. To introduce you to the neuroscience of emotion, we will start with the basics and describe what makes up an emotion on a general level. In the first video, we describe how a stimuli can lead to an emotion. And in the second video, we go through how an emotion is expressed. We think that this can be a good preparation for you to study complex emotions, emotion disorders, emotion regulation, and the theory of psychiatric treatment.
Most emotions share the same core features. 1. They are generally initiated in response to an internal or external stimuli, such as visual inputs, smells, signals from the body, or memories. 2. They have a communicative expression, which can be manifested in terms of facial mimics, body language, or alterations in speech. Some mean emotions are a complementary way of communicating that works also when words are not possible, such as when you interact with a little child or someone with another language. 3. Emotions affect the autonomous functions in the body. For example, they can lead to a changed heart frequency and respiration pattern, reddening or sweating. 4. They also increase the tendency to act. For example, emotions can lead you to approach someone, to wanting to give a hug, to back off, or to show aggression. And 5. Finally, the most apparent feature of an emotion is it makes you feel something. You get a subjective experience that you recognize as an emotion. When the emotion subsides, it can leave a memory that affects your future behavior. The central nervous system is one of only few organs in the body that has an ability to remember. An emotional memory can be, for example, you start associating the looks of a certain face with a positive feeling if that person has been nice to you, or a road with a good feeling if it has led you right. This helps you making decisions in your future life.
How does the brain know what incoming signals should result in an emotion? Well, some neural impulses are dedicated to become emotions already before they enter the brain, such as pain signals, neural impulses from sensual touch, or hunger signals. And this is hardwired in the nervous systems. Other incoming signals need processing in higher brain centers to be assessed whether they should be handled in the emotional system or not. Some factors seem to be more important than others in this process. For example, things that happen that are unexpected or new tend to release an emotion more often than things that are well known to the individual. Things that are of interest to know of in relation to the goals you have set up also tend to lead to an emotion more often than others. It has to be an information that is relevant to the individual, at least potentially, to give rise to an emotion.
As you understand, all these different kinds of higher evaluations cannot take place in a single brain region. There isn't any one brain region that can do all of this on its own. Instead, collaborations of several different brain regions are needed. At the brainstem level, or a little bit further up on the thalamic level, some information can be interpreted as emotionally relevant, even if the information at this level is still very raw and unprocessed. Like if something is very unexpected. For example, if you hear a sudden loud noise when you were prepared for silence. Further up after the thalamus, other kinds of information are decoded that can lead to emotion reactions. Most importantly, this happens in the ventral flow of the brain, occipitotemporally. Here lies a row of limbic and paralimbic structures that each contribute in an important way to the decoding of emotionally relevant information. For example, the temporal cortex that helps you decode whether the content of auditory and visual information is of personal interest to you. The hippocampus, which sets new impressions in relation to autobiographical memories and judge whether the things you're now experiencing are salient or not. The amygdala, which compares the impressions to older emotional memories. And the insular cortex, which signals if anything in the internal bodily environment should give rise to an emotion. Finally, the prefrontal cortex, one of the highest centers in the brain, only reached by information that has already been processed on a lower level, sets the incoming information in relation to expectations and goals for your current behavior, and is critical in judging whether this new piece of information is of interest for your ongoing actions, and therefore should give rise to an emotion. The ventromedial prefrontal cortex is extra important since it has a key role in assessing cues related to social behavior and risk assessment. On all of these levels, it is possible to, consciously or unconsciously, regulate the processing of incoming information by filtering out unwanted info or by increasing the amplitude of such information that is important at the moment.